let me just say the word about the links. That's a new lab that we co-founded a year ago. The idea was to put together in the same floor of the same building experts coming both from the industry and from academia. And today we are 65 people working on all these topics that we were discussing around here. The target is to close the gap we used to have in France and we still have between nice ideas and products as much as we can. And if I'm talking about this, is because, of course, we are a very open lab. We are welcoming researchers from all over the world. And is that okay? Yeah. So if you are interested in knowing better what this is about and in visiting us, I'll be very glad to talk to you during the break. The second thing is that I'm no longer the RAD CTO. After I co-founded this research lab, I'm still connected with RAD as a strategic advisor. So what I'm trying to do here is first I will focus on the challenges of the evolution towards the cloud as we see them in this laboratory, the links. And as I said before, my main trigger here is try to find collaboration with all of you. And when doing so, when talking about the cloud and its challenges, I will give a specific focus on how the service providers see the opportunity of the cloud, or at least how we see at RAD this opportunity for the service providers, and of course we are working with them very closely. So this is the global idea. Let me start from a service perspective. I'm sure that you are familiar with all this stuff, and I will do it very fast, but it's just to trigger some ideas. Yesterday, Dvora was talking about health, mobile health. Today we have plenty of nice appliances that will help us to move in what she explained yesterday. What you see here is I don't know if there is a laser. Oh. Yeah. What you see here is something that you can buy today. It's a lens that is increasing the quality of your vision, but at the same time is monitoring the level of sugar you have in the body. Think about diabetic people. It is the energy is coming from the electromagnetic environment, and if it detects that the level of sugar is too high, it will blink. So you will see that you have a problem. The next step, and we have already devices like this, is that this tiny appliance will communicate through a radio link. Of course, you cannot imagine having a 3G interface there, right? But you can have some radio communication, for example, to talk with your smartphone. The smartphone will become a gateway to connect to the medical center. Now, the point is that our smartphones will become the gateway between our personal area networks and something else. By doing so, they will collect a huge amount of data. This data will not be sent to the cloud as it is. It will be stored, pre-processed. You will transform this data into some information, into some knowledge of utility. And the key point here is that by doing so, what you are doing somehow is you are building an architecture where the cloud is coming out from the very big data centers and moving closer to the end user, including till your smartphone. When today we talk about a mobile cloud, we maybe talk about accessing the cloud through your mobile device, which is very basic. What we are talking here is about the cloud spreading out of the data centers, reaching the network in different places, and I'll come back to this later on, and even reaching some gateways as you could have in your smartphone. Now, this is completely changing several paradigms. First of all, the number of devices, as we know, is exploding, and the architecture has to change. Second, if you think about security, let me give you a second example. The first pacemaker that was connected to the network was implanted in 2009. So that's something we know how to do, right? Now, if you have a device like this that is connected to the network and there is an attack, someone can kill you through the network. Of course, it's half of a joke, but cybercrime is something more than what we are used to think about. It's not attacking your data, it's attacking more, attacking your person. So the security paradigm is changing, the network architecture is changing, and I'll come back to this later on. Another topic that is very interesting for us these days is all about energy. You may know, maybe you know that the electricity companies have the following problem. The 10% peak load arise a couple of days a year. Depends on the country, between 2 and 10 days per year. So they are investing 10% of the capex for something that they are not using most of the time. So they, of course, want to shape this. And one way to shape this is the following. Let's get inside the households, understand the different appliances that they are there consuming energy, and to schedule in a smart way when these appliances are being used. I will not go into all the details of this here, but we are working in the lab together with Electricity of France, which is the national electricity operator, 30 million clients, on defining these architectures. And here is exactly the same thing. We are going to have a smart energy box in the household, in the building, and the enterprise that, based on an Internet of Things approach, will learn what is going on around, store information, pre-process information, talk with some centralized architecture, but will become an integral part of the cloud. Because part of the data will remain stored there, part of the processing will be done there. So that's something we are doing with Electricity of France. We are maybe not yet signed, but maybe starting something in transport together with Cisco. Cisco is working with General Motors in vehicular networking. The idea is, in a futuristic approach, to have electrical cars that will recover energy from the road. It's about some induction process I will not describe here, but in order to do so, you need to go into ad hoc networking. You need to understand the different appliances that you have in the different cars. They have to coordinate each other. This is also about the Internet of Things. And here again, you will have some local information stored and pre-processed. So this is something that we are starting with Cisco, as I mentioned before. And I could continue like this. Just one word. What we are foreseeing is that, as I said before, the cloud needs to move somehow out from these big data centers where it is concentrated today. And for this, we need some different type of architectures we are dealing with. So this is what I mentioned before about the grid. I will skip it for the time being. So this was a little bit about the Internet of Things and how we need to interconnect all these trillions one day of appliances through a different architecture. I will come back to this in a minute. And this is just some different technologies we are trying to understand how they will impact the things I was mentioned before about the Internet of Things. Maybe you've heard about these projects in Berkeley about the electronic skin, which is about having a full computer printed in a very thin sheet, which is very stretchy, robust, and so on and so forth. This will, of course, facilitate all the health story I was mentioning before. Another project that we are trying to understand how it will impact the things we are saying is about the nanobots. Maybe you've heard about this as well. Here the idea is that nanoscientists are working on a kind of white cells that are, of course, synthetic, that will circulate in your body and clean your cholesterol, for example. And these devices will communicate, not in the way we are familiar with. It will be through markers, biological and chemistry markers, but it's something that we need also to take into account when talking about the Internet of Things. I think that some of the approaches we are using could be applicable in this case. The last thing we are trying to understand, and this is a thing we are trying to understand. We're not familiar with this at all. We're not experts on this. We're trying just to understand and how to use our knowledge in these different environments. We have a group of people working around this, trying to better understand it. But the last thing is human-brain interface evolutions. And a lot of progress has been done in this arena in the last years. You can go to a show today and check the possibility of in front of TV changing the channel just through a brain-machine interface. It is working. It's not working so well, but start to work. Maybe you heard about this DARPA project where they are working on helping or on facilitating a solution where the soldiers in the field will just talk through telepathy based on this type of devices. And the reason why I am talking about this and the reason why we are interested on this is because of that. Yesterday when I was talking about the software-defined networking, I reminded this very old sentence. Brian Hayes is not a scientist. He's a journalist that writes about science. And you remember, I think that in the room there are a lot of people coming from the telecommunication world, as I do. And we like to say 20 years ago that the telephony network was the largest machine that was ever built. And that when an end user is dialing, he's just programming this big machine. Now, if you forget about the internet, as you think about it just as a milestone towards the Internet of Things, of course the machines where we are building today are much bigger. And if we connect all the things through the Internet of Things to the internet, it's like the whole world is becoming a unique machine. And if you think about this brain-machine interface, it's like you can extend your body for controlling all these type of things. So this is not science fiction. It's things that we have started to build, although, of course, reaching this is completely out of the scope today. Maybe you have read some documents by Ray Kurzweil. He wrote a book that was translated in French into this name, Humanity 2.0. And Raymond Kurzweil is not a science fiction writer. He's a computer scientist. So we are trying to understand what can be done in this field. So let me close this parenthesis. I come back to the real world. So as I mentioned before, we are interested in the Internet of Things and how this will interwork with the cloud arena. I think you are all familiar with what is the Internet of Things about. I just came from Tel Aviv. I gave a talk there about the machine-to-machine, and this is what basically differentiates Internet of Things from machine-to-machine. In the machine-to-machine, usually what the market understands is machines, devices, appliances that are connected to the network, talk with an information system, and the information system will learn about these objects and control them. What we are talking about here is something much more general. It's the possibility of the different things in the environment to self-identify, to explain what they are capable to do, to self-discover, self-organize, geolocalize in order to dynamically create new services through a self-organization. And that's another topic that we are dealing with, which is how to enable these type of things. Because devices that are already today connected to the network, that's very easy. There are plenty of examples all over. But an architecture that will allow to do what I just described in a few words before needs to be defined still today. So that's a very simplistic example, and I will not go through all the details, but imagine that this is a smart building. You arrive to the building, you don't know anything about the building, and you want to discover the services that are available there through the Internet of Things. The type of architectures we are working on are based on semantics. The idea is having gateways, let's say, in each room, in each floor, that will self-discover through a semantic approach the different things that are in the environment. And basically what they are going to do is to talk each other a semantic routing approach with a centralized device for the building that will aggregate all this information and public this information over the internet. So just to summarize very much what we are doing is, in the internet, of course, you have this approach which is based in IP address identification and routing based on IP addresses. Here we are taking a semantic approach where instead of defining objects, we are naming the objects, and behind the name you have a semantic description of this object, and we are moving from the routing based on addresses into routing based on those semantics in order to build an architecture where you can dynamically discover the different services that are available in the environment and orchestrate new services. And the point is that you can do this in a very distributed way, or you can do this in a very centralized way, where each object in the environment will register itself in a cloud that will do all this job of orchestration and self-organization. This is something we are doing with Alcatel-Lucent. We are working, I mean, it's related with what Rock was saying before, between the full distribution and the full centralization. What is the right solution? That's difficult to answer. It depends very much on the context. So we are working with Alcatel-Lucent in some specific environments and finding what are, in this context, the optimal solution, optimal with respect to a set of metrics that, of course, I will not have time to describe here. But that's the type of things we are trying to do, understanding how the Internet of Things as a way to collect information, to process local information in the cloud, could they live together in an efficient way. Okay, so this was the first part of my presentation, the cloud and the IoT are working together. Let's move into my second part, which is as well about the cloud, but the more short-term, more focus on the positioning of the carriers, the network providers, into this environment. So I will say things that, of course, everyone knows that well, but just to position the next part of my talk. So as we all know, the broadband access to the internet has facilitated the arrival of what we call the over-the-top companies, the ones that we know that well, and the incumbent service providers are suffering a lot for many reasons. First of all, because some of these over-the-top companies like Skype are competing. Today, Skype is the #1 international telephony service providers worldwide, and it has been the case for the last 3 years. But as we all know, they came also with innovative services that we know that well, that trigger in the users some expectations that the incumbent service providers are not really answering. That's one thing. We all know about the cloud story. We've been talking about this during the whole 2 days, a very interesting vision on this. And what we see is that these companies that they run over the top, that are not investing really in the infrastructure, they have a big advantage. From day zero, they are global because they run over the internet. What the service providers are trying to do is to fight back and to move into this cloud arena. The problem they have is that they are not global. First problem, and I come back to this in a minute when talking about the federation. But the advantage they have is that they control their networks. They can control quality, they can control security, they can comply with the different policies and so on and so forth. So the key question is how they can leverage their assets, the control in the network and the clients they have to move into an integrated network cloud approach. And this is what I will talk about in the next 10 minutes. This is related with the explosion of content that we are familiar with and the need for content delivery networks. It is also related with the Internet of Things I just mentioned before. And from a carrier point of view, this is imposing two things. First of all, the Internet of Things is pushing new constraints in terms of quality. That's the things I mentioned before. This is specific type of traffic. Just to give an example, it's not so clear what I'm saying, sorry. Think about the mobile networks. The mobile networks were designed for a specific type of traffic, right? And even when you go into the 4G, you can realize that the 4G is not well suited to deal with the traffic that the Internet of Things, as described before, will generate. By the way, the standardization bodies are working on this, but there are very interesting problems for the scientific wall behind this question. And of course, the Internet of Things is a source of content. I mentioned this before. Let me focus in this part, in the network cloud story, and I will finish with this in the coming 5 minutes. I'm sorry for that. Okay. As I mentioned before, when talking about the cloud, you can run the cloud over the internet, the over-the-top approach, or you can take a service provider approach and say, I control the network and will provide an access to the cloud that is well controlled in terms of quality, in terms of security. Now, if you look to what is going on the field today, I'm sorry I didn't put here the right presentation. This is a mess. But I will fix it. So, as I mentioned before, over the top, one approach. The second approach is to run this cloud over a well-controlled infrastructure. As you know, one of the services that the carriers were providing with very high revenues till recent time is VPNs. VPN is a solution just to give the feeling to a company that they have a private network interconnecting all the sites. But in fact, it's not a private network. They are just sharing the infrastructure of a carrier. This was a very powerful service in terms of revenue for carriers during many years. The revenues these days are going down, and they want to fight back against the over-the-top players I mentioned before. So one of the problems they have with this VPN infrastructure is that although we've been talking about flexible network for many years, those VPNs are not elastic at all. They cannot easily adapt to the evolution of the traffic. You buy a VPN, basically you buy a certain amount of bandwidth, a certain level of quality of service that you cannot dynamically adapt to your specific requirements at a given time. And as we know, when we are connecting to a cloud, these requirements are changing very dynamically. So the first approach that we're pushing to introduce over the VPN's flexibility was what is called application awareness. The idea is the following. You have a VPN with a certain amount of resources. You cannot easily change these resources because it's a contract you have with the service providers. You don't have a signaling that allows you to dynamically adapt the resources to your requirements. So what you're going to do, you're going to adapt the behavior of the traffic to the resources that are available. How do you do so? If you're a client, you put equipment in the edge of the network, as I am indicating here, that will understand the structure of your traffic and will dynamically schedule this traffic among the different sites of the VPN in order to optimize the resources you are paying for. This is what we call application awareness. There are solutions like this for many years in the market. The end customers, the ones that were buying the VPNs, were deploying this application awareness in order to have visibility on how they are using the infrastructure and in order to optimize this infrastructure they are paying for. So you buy a VPN, the VPN is static. You cannot dynamically adapt the resources you are paying for. In many cases, they will not be well adapted to your specific requirements at a given time. So what do? You put intelligence in the edge. This intelligence in the edge will understand the structure of the traffic, how this is changing, will understand which applications are critical for the user, which applications have specific QoS requirements, and will dynamically adapt the way they schedule the traffic at the entrance of the network. That's something companies are doing over the VPNs. The carriers understood that there were a market behind this, and they started to provide this type of service as a service. Instead of the end user buying the boxes to implement this approach, the idea was, let's do it the other way. We deploy the infrastructure as a service provider, and we sell this capability as a service. They started, several of them, 4 or 5 years ago, and it was a complete failure. And here I come back again to what Rock was saying. You can have a technology which is very interesting, that you can prove that is optimal in many regards, and has no success in the market at all. And one of the reasons, just to push forward these ideas, why this didn't work in the market is because the sales forces of the carriers didn't know how to sell it. Just because of that. I mean, there were other reasons, but when you talk with the managers of the business units that were pushing these ideas, that was the main reason why. Now, this story, why I'm talking about this, it didn't work, but the story is coming back top down now with the cloud. Because as has been repeated many times during these days, when you move into a cloud architecture, you need network elasticity. You need the network to adapt to the changes that you have because, for example, you're moving a virtual machine or a set of virtual machines from one data center to another. So we are working with carriers to leverage these type of technologies in order to deal with the requirements of these specific cases coming from the cloud arena. Now, I will skip this, running out of time. One of the companies we are working with for this type of things is Orange. Orange has opened a service that they call a VPN gallery, business VPN gallery. What is the idea here? The idea is we provide VPNs historically, those that are here. You have an infrastructure. You share this infrastructure with different clients. The green, the red, you provide VPNs. And now they extend the VPN by dynamically connecting to the VPNs on demand cloud services. So they bundled in a smart way the VPN services with cloud services. Some of those cloud services are their own cloud services. Some of them are coming from third parties. And the idea is, at the edge of this infrastructure, to put the intelligence I mentioned before in order to dynamically adapt the way you use these VPNs that are already established to the change of the conditions of the traffic, because the user has set up an access to a new cloud service that is generating a different traffic structure. So this is the way the carriers are starting to get into this cloud market. They are buying, as you maybe are familiar with, cloud companies, cloud service providers, that they are not integrated them in their infrastructure. They just keep them as independent business units, but they connect them in an efficient way through, for example, the methodology I mentioned before. So that's one of the things we're doing with them. Now, sorry. If you look to the global picture, basically what we are saying is the following. This is a global architecture to provide cloud services. I will not go into all the details, of course, here. But basically what you see is, on the one hand, the networks that are, for example, providing VPNs. And on the other hand, these cloud service providers. Even if it is the same player, the carrier, that is providing the both, still we are talking about an over-the-top approach, in the sense that the cloud infrastructure is not integrated with the network infrastructure. You do some optimization just at the edge of the network in order to deal correctly with the traffic and the evolution of the traffic due to the cloud services you are providing. But we are working with them, with the service providers, in moving forward. Of course, the service providers can have in their data centers their own services. That's not an issue. But the next step is to say the following. As a carrier, you have access to a different point of presences that you have in the path between the client and the cloud locations, the data center locations. And if, because you have a visibility there, you can put intelligence in this place to monitor what's going on. To monitor, on the one hand, the resources you are using, to monitor the quality you are providing, and so on and so forth. And the idea is to push this monitoring till the CPE, the equipment that is deployed as the customer premises. From there, you can very nicely evaluate end-to-end the quality, the service, whether you are conform or not with the service level agreement you are selling. This monitoring end-to-end of different type of resources, cloud resources, network resources, all together, is not an easy task, as we know, in the scientific world. That's something we are dealing with as well. And of course, with the algorithms to transform all this data into some useful information. The next step, and this is what I wanted to mainly to highlight, is not only to use this point of presence to do all this monitoring, but to move part of the cloud infrastructure, part of the cloud resources into this point of presences. To have a better architecture where you will locate the pieces of your cloud nearby the end users. Something that has been discussed yesterday, in particular during the panel, if you remember. And that is one of the advantages of the carriers. They have these locations, and they would like to leverage it. How to do it is not clear. Whether it is an advantage between centralized and distributed is not clear. So we are trying to model this, for example, as one hint, using results as the one that Jen here was pushing about the network embedding, and trying to understand how to use this type of methodology in this specific environment. And as I mentioned before, when pushing a cloud technology into the network, we are even thinking about pushing it till the CPE, having a cloud intelligence in the CPE that historically was just used to connect the site of the company to the infrastructure. And of course, once you have moved part of the cloud infrastructure into the point of presences of the carriers, the question is, why do I need in this point of presence two different type of resources? A router on the one hand, and a storage, caching, and so on and so forth in the other hand. We are more and more in a virtualized world, and here I will say something that is trivial, and it is related with many talks we had before. In the future, maybe we are going to see one day generic hardware here that will be virtualized. One slice used for the routing, another slice used for one cloud provider, and a third one for another cloud provider, and so on and so forth. The whole thing in an SDN approach, controls through OpenFlow and a ++, and so on and so forth. We had very nice talks about this. I'll not come back to that. But we are mainly focused on the previous steps that I highlighted before reaching this final game of a fully virtualized, fully integrated, fully virtualized network cloud, because at the end of the day, all the equipment could be the same from the hardware point of view. So if I focus on what RAD is doing in this game, RAD is a manufacturer of telecom equipment, mainly focused in the access, and with a strong positioning in CPEs, customer premise equipment. And as I mentioned before, the idea is that in order to have an optimal utilization of the resources end-to-end, and to guarantee a service level agreement, you need to monitor the usage of resources, and the best way to do so is starting from the client side. So if you are a carrier, you are terminating your infrastructure with this CPE, and from there, you want to understand what's going on. So the idea is to put a cloud intelligence in this type of devices that, by the way, this CPE later on, they will collect information, they will send information to a centralized machine that will optimize the infrastructure and will tell this specific CPE what to do. For example, based on a flow-aware networking per flow, to understand how to do a load balancing between different accesses, between different clouds, and so on and so forth. So just to summarize, what I was trying to highlight is the fact that, as we all know, the carriers are suffering from all this movement into these services that the over-the-top companies are providing today, into all that is facilitated by this cloud history. They want to fight back by integrating cloud services, cloud infrastructure into their solutions, both from the infrastructure point of view and from the service point of view. And what we see is that at the end of the day, we are facing a world where we are going to have a very large diversity of players using a large diversity of technologies. And yesterday we were talking about the need of federation. The colleagues from ALU, from Alcatel-Lucent, were referring to the need for federation. And as I mentioned from my questions, it's clear that because of this large diversity, the market will benefit. The end users will significantly benefit from the federation of these different type of service providers from the different cloud service providers, cloud infrastructure. We've been talking about this for many years already, cloud portability, inter-cloud, and so on and so forth. The point is that that's a requirement. From the technological point of view, it's something that is, of course, feasible. But what is not clear at all is whether the market will move into this direction. If you think about content delivery networks, it's exactly the same problem. You have a global content delivery networks like Akamai, and we saw plenty of small CDNs to come to the market. They were not global. In order to become global, they need to federate. The standards for federation were there. There is a working group in the IETF called CDNI that started working 10 years ago. But nothing happened. And in my opinion, nothing will happen in the future, because Akamai and others have a very strong position. In the cloud, I am afraid we are going to face exactly the same thing. Although from the technological point of view it's feasible, although some people are working on trying to understand if good standards could help, we have already very strong companies that took place in the market. So I am afraid that moving into such a federation will not be, from the market point of view, really feasible. So that's a main challenge, to understand the economics behind this market, and from there, try to conclude whether it makes sense to invest research effort, standardization effort into this federation story. Another main challenge I mentioned already is end-to-end SLAs. This requires, first of all, to monitoring what's going on in the network, in the cloud infrastructure, end-to-end. There are plenty of different parameters we have to deal with. The amount of information you need to collect is absolutely huge, and to process this information is a big, big challenge. Another related challenge is the fact that the end user don't have visibility today. We start to give them visibility of what's going on in the network. They have some visibility of what's going on in some cloud services. Clearly, they don't have an end-to-end visibility, and they don't have visibility in a way that they can use it as information to take decisions based on this. The networks are not elastic today. Although the technology is there for 20 years, from the ATM era, we have a very good signaling to dynamically allocate resources over a network. That's not being used. And it will never be used, in my point of view, not in the 5 coming years, at least. So our networks are not elastic at all. The cloud is becoming very elastic. We need to transform the network into something much more elastic. I gave you a hint of how this can be done at the edge. It's clearly not enough. There are new services, new paradigms that are imposing new traffic structures, new types of SLAs that we don't clearly know how to deal with. And at the end of the day, providing SLAs is related to the way you allocate resources, and we don't know how to embed the requirements related with cloud services in a smart way over the cloud and network resources jointly all together for global optimization. The issue of virtual machines mobility, there are plenty of possibilities from the technological point of view to move virtual machines inside the data center. I will not go into the details of the performances of this, but moving virtual machines between data centers remain a problem today, and the way to reorganize your network to deal efficiently in a context where you do have such a mobility is a clear challenge today. Security, I mean, we can speak hours about the security for the cloud. Most of the people, when referring to this, is referring to the fact that you need to protect the data and so on and so forth. But as I mentioned before, there are new paradigms regarding security in this new era. I was talking about the real cybercrime, and you can have many other examples of things that were not feasible before, new type of attacks that become real when you move into this IoT cloud integration. And of course, compliance with regulation. In Europe, for example, if you're using cloud services, I mean, cloud providers that are following the policies, as most of them are, they cannot move data out of Europe. In Germany, there are very strong policies regarding the way you use or you provide cloud services. How to control whether these policies are being implemented or not is also an interesting challenge. So just to finish with this presentation, we used to have a telecommunication market which scope was very clearly identified. Everyone knew exactly what does it mean to be a telecommunication company historically. That's not true any longer. The borders between the different industries are completely vanishing. That's the consequence of this is, of course, that competition for service providers is harder than ever. Key players, the ILECs, the incumbent carriers, are suffering significantly, most of them, of this. They are redefining these strategies, and the cloud is one of the vectors for redefining the strategy, but the movement today is very slow for them. They need to move into new business models that are not well designed today, and we could help them to do this movement. We are working with them with this. The regulation of these markets are not well adapted any longer. The regulation in the telecom market was done for a market that was, again, very well designed. The relevant market of the regulation is very, very small compared with the scope of what the industry is doing today. So that's something that needs to be rethinked that way as well. And as I mentioned before, all these three problems are even more critical when we come back to this not so smart sentence I pushed before. The Internet of Things is transforming our lifestyle, is transforming the industrial process, is transforming the business processes. We are moving into a single programmable world, the whole world becoming a single global programmable machine. And this is completely changing our lifestyles, as I said before. But for the topic I was treating at the end, the service provider approach is completely changing their business. Their business models are becoming completely obsolete. And I hope from our side we can provide a little help in order to redefine these business models. This is what we are doing with them. I'm talking here about what we are doing at the links, and I will close my talk by saying that these are a short vision of different topics we are covering. As I said at the beginning, I will be more than glad to discuss with you and to welcome you in this new lab in Paris. Thank you very much.